Let's consider the following problem. Consider the following model of the hydrogen atom. A small point charge plus Q is surrounded by a spherical distribution of negative charge in the form rho is equal to rho 0 exponent to minus r over r0. Using the fact the hydrogen atom is neutral, find rho 0 in terms of Q and R naught. Alright, so this is a very interesting problem. Okay, let's basically start by drawing a picture. So what you have is at the center you have a positive charge plus Q, and you're surrounded by a cloud of electrons, right, whose total charge must be such that basically it neutralizes this one. So the total charge of the electrons must be minus Q, right? Now they follow a special distribution. The distribution is rho is equal to rho naught. Okay, so this is, let's rewrite this. Just rho as a function of r is equal to rho naught exponent to minus r over r naught. Okay, all right, so let's basically do the integral over the entire electron cloud and get that charge. So the integral of the entire electron cloud to get the charge of the electron cloud, Q, is equal to integral of rho dV. All right, and rho dV is just basically integral of 4 pi r squared rho. Now at this point you have to basically keep in mind what are your limits of integration. Where are you integrating from to where are you integrating to? Okay, and in this case where you're integrating from is basically from r equals 0 all the way out to infinity. So the integral is from 0 to infinity. Okay, alright, so let's just basically start plugging stuff in. Okay, this is integral from 0 to infinity 4 pi r squared. Rho is what? Rho 0 exponent minus r over r naught dr, and this ultimately has to equal such that it is cancels out the positive charge in the middle. This is minus q. Okay, so this is all we need, and now we just need to do this integral. Okay, now this integral here is a very common integral, right? And the one trick to know is to know how to integrate by parts. So this is a very important concept to know. How do we integrate by parts? Okay, so the important thing of integrating parts is to recall that duv, okay, where these are some functions here, is equal to u dv plus v du. Now this looks pretty simple, right? This is just the multiplication rule, right? Now, so if I integrate this entire thing, okay, that means that integral of this thing is just uv is equal to integral of u dv plus v du, or if I want to choose it, integral of u dv is equal to uv minus v du. Now this looks all pretty innocuous, right? Until you start thinking about what is u and what is v, right? And for exponential problems like this, what you want to choose is you want to choose this thing to be u and the something else to be v, right? So let's bring out all the constants first out to just clean up a little bit. So this is going to be equal to 4 pi rho 0 integral 0 to infinity r squared exponent to minus r over r0 dr. Okay, so now which one is u and which one is v? Like I said, like you want the exponent to be u and this one to be, I'm sorry, this should be dv and this one should be u. Okay, and the reason why is that when I flip this like this, this integral here, when I flip this, I'm going to take a du here, which is derivative of this guy, and I take integral of u of v, but integral of v of an exponent is pretty simple. It's just going to be the exponent back again. So that's why you want to do this. All right. So let's just do one step, and we'll look at what we get. Right. So this is going to be equal to 4 pi rho 0. Okay. So now this is u, this is v. Okay. So that means v is equal to, if that's dv, is equal to r0 exponent to minus r over r naught. Okay, with a minus sign out in front. Okay, so let's write that down. So it's going to be basically, that's v u is going to be equal to r squared, and then du is equal to 2r. All right, that's pretty easy. Okay, so that's dv, that's u. Okay, it's beautiful. So now let's just see. So I'm going to have to write down uv. uv is going to be r squared. V is going to be r naught with a minus sign, exponent minus r over r naught. And this term now is going to be evaluated between 0 and infinity. Okay, minus, okay, v, which is this one, a minus is a plus, integral of r0. Okay, let's see, I'm running out of room. Let's start a new line. Plus integral 0 to infinity of r0. Okay, exponent minus r over r naught. That's very nice. And now basically I need du, which is going to be 2r. Okay, dr. Okay, now if you look at this thing carefully, the key trick is here. Okay, I'm going to evaluate r at infinity and 0. But r infinity makes this term go to 0, and r0 makes this term go to 0. So this entire term is 0. Okay, now you may think, okay, I really haven't gotten anywhere because all I've shown is that this entire term now is just going to be equal to, now the 2 comes out front, 8 pi rho 0 integral from 0 to infinity of r0 exponent minus r over r naught dr. Okay, but in fact I have made some progress. All right, so I do it one more time. Let this become u, and let this become dv. Okay, this will now become, one more time integrating parts, 8 pi rho 0. Okay, so then in that case dv is the same as before. This will just be again r0 squared exponent minus r over r naught with minus sign, evaluate at 0 and infinity. Okay, minus a minus is a plus. V is now this one, so I have one factor of r naught here, so it's going to be integral from 0 to infinity of r naught squared exponent minus r over r naught. Good. Du in this case is going to be 1, right? So that's du is 1 times dr. Okay, and if you look very carefully, do the same evaluation. Evaluate this at infinity, this term goes to 0. Evaluate this at 0, this term goes to 0. So this entire thing goes to 0. Right? And now you are done. Amazingly enough, this is going to be equal to 8 pi rho 0 r0 squared integral of 0 to infinity exponent minus r over r0 dr. And evaluating this integral just gives me another factor of r0. Okay, so this is just going to be simply be equal to 8 pi rho 0 r0 cubed. Has the right units now, right? This is a unit of volume. All right, there's some stupid constant that you had to basically calculate up front. And this is a charge density, so this has to be equal to charge. What was that charge? Minus q. Okay, so now I can take this thing and evaluate what rho 0 has to be. Rho 0 is just equal to minus q over 8 pi r0 cubed. And we are done. All right, so that was a very nice problem, basically showing us how the importance of integrating by parts in order to basically get the right answer. Okay, hope that was helpful.